Hello everyone, this is Shrawan Sir, making maths simple for you. Welcome to my YouTube channel, Karna Maths Academy. Today's topic is Principle of Mathematical Induction. Here we go. Dear students, in this video, we are going to prove one of the most important formula of sequence and series, which is the sum of the cubes of first n natural numbers by using the principle of mathematical induction. Dear students, in the previous video, already we have proved the sum of the first n natural numbers by using the principle of mathematical induction. In the second video, already we have proved the sum of the square of natural numbers by using the principle of mathematical induction. Now in this video, we are going to prove the sum of the cubes of the first n natural numbers by using the principle of mathematical induction. Dear students, the question is, one cube plus 2 cube plus 3 cube plus n cube, where n is a natural number, is equal to which is equal to n times n plus 1 divided by 2 whole square. Dear students, we know that the sum of the cubes of first n natural number is given by the formula n times n plus 1 divided by 2 whole square. So dear students, in the exercise of sequence and series, already we have proved this by using the formula of sequence and series. But in this exercise, we are not going to use any formula because induction method means making observations or making experiments and solving the problems. So dear students, we have already discussed the basic principle of the principle of mathematical induction in previous video. So if you have not watched, please watch it. So dear students, according to the principle of mathematical induction, in order to prove any formula or any theorem by using the principle of mathematical induction, at first we have to suppose the given statement as Pn. Then after supposing the given statement as Pn, we suppose that the given statement is true for n equals 1. Then in the second step, we assume that the given statement is true for n equals k. And by assuming that the statement is true for n equals k, we prove that the given statement is true for n equals k plus 1. So dear students, mainly there are three steps in the principle of mathematical induction, showing the statement is true for n equals to 1, then showing the statement is true for n equals k plus 1 by assuming that the statement is true for n equals to k. So here we go. So let's use the principle of mathematical induction to prove this formula. Solution. Dear students, at first we suppose the given statement as Pn. Let Pn be the given statement. Dear students, a statement involving natural number we suppose as Pn. Therefore, the given statement is Pn such that 1 cube plus 2 cube plus 3 cube. That means we are taking the cubes of first n natural numbers, which we have to show equal to n times n plus 1 divided by 2 whole square. So dear students, we have supposed the given statement as Pn. Now according to the principle of mathematical induction, at first we show that the given statement is true for n equals 1. That means if we take the number of term 1, then the value of LHS and the value of RHS must be equal. So let us take the value of n equals 1. When n is equal to 1, that means if we take the number of term 1, then in left hand side we'll have only one term. In LHS, that means in the left hand side of the given statement, we have the term 1 cube. 1 cube means 1 into 1 into 1, that means we get 1. Now we take RHS and put the value of n 1. So dear students, after putting the value of n equals 1 in the right hand side, we should get LHS and RHS equal. That means from RHS also we must get the value equals to 1. So let's put the value of n 1 in the expression of the right hand side. The value of n is 1, so we put the value of n 1. So dear students, if we put the value of n 1, if we replace n with 1, then we get 1. Putting the value of n 1, then we get 1 plus 1 divided by 2. So dear students, after adding 1 and 1 we get 2. That means we get 2 and 2, if we cancel then we get 1 square. Which is equal to 1. 1 square means 1 times 1. So dear students, we see that when we take the value of n equals 1 and put the value of n 1 in right hand side, we get the value of right hand side equals to 1. And if we take n equals 1, that means if we take just one term, then in the LHS we have got 1 cube, which is also equal to 1. It shows that the given statement is true for n equals to 1. That means we can say that P1 is 2. So let's write down the conclusion of the first step. Dear students, after showing LHS equal to RHS, now we have to write down the conclusion of the first step. Dear students, we have got LHS equal to RHS. We have got the value of LHS and RHS equal. It shows that P1 is 2. P1 is 2. If we put the value of n1 in our statement, then it will be P1. That means the given statement is true for n equals to 1. Dear students, now according to the principle of mathematical induction, the second step is we have to assume that the given statement is true for a natural number n equals k. So dear students, now let's go to the next page. The second step is, let us assume that or we can say, let us suppose that the given statement that means Pn is true for n equals k. Dear students, we have supposed that the given statement is true for n equals k. So now if we put the value of n k in our given statement, dear students, our given statement is our given statement is 1q plus 2q plus dot 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 plus n cube. That means the sum of the cubes of first n natural number is equal to n times n plus 1 over 2 whole square. So dear students, now we have to assume that our statement is true for n equals k. So if we put the value of n k in our given statement, then we'll get pk. That means the given statement is such that 1q plus 2q plus 3q plus kq. We have put the value of n k on both sides, on left hand side and on the right hand side. So if we put the value of n k, then we get kq equals to, again putting the value of n k on the right hand side, k, if we put the value of n k on right hand side, then we get k plus 1 divided by 2 whole square. And we suppose this equation as 1. So this means according to the principle of mathematical induction, after showing the given statement is true for n equals 1, we have to suppose that the given statement is true for n equals k. And by supposing that the given statement is true for n equals k, we have to show that the given statement is true for n equals k plus 1. That means if we add one more term, then again we get the given statement true. That means we'll get the value of LHS and RHS equal. So dear students, now the third step is, now we show that Pn is true for Pn, that means our given statement is true for n equals k plus 1 when pk is true. That means if we take the value, if we suppose that the given statement is true for n equals to k, that means if pk is true, then we show that the given statement is also true for n equals k plus 1. So this is the third step of the principle of mathematical induction. Dear students, now we are going to show that the given statement is true for n equals k plus 1. So now we'll put the value of nk plus 1. Dear students, now we put the value of nk plus 1 in our given statement. Dear students, our given statement is 1q plus 2q plus 3q plus dot 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 plus nq, which is equal to nn plus 1 divided by 2 whole square. So now we are going to show that this statement is also true for n equals to k plus 1. So we have to replace n with k plus 1 on both sides. So we'll put the value of n k plus 1 on the left hand side, and again we'll put the value of n k plus 1 on the right hand side. So dear students, our statement is the sum of the cubes of first n natural number is nn plus 1 divided by 2 whole square. So now we are going to put the value of nk plus 1 on both sides, LHS and RHS. So dear students, we know that the statement is true when the value of n is k. So we'll write down 1q plus 2q plus 3q plus kq. That means up to kth term, the given statement is already true. So we'll copy from the first term to the kth term. Then after that, we have to add one more extra term. That means we have to add k plus 1th term. So dear students, if we put the value of k, if we put the value of n k plus 1, because we are going to prove this statement is true for n equals k plus 1. So if we put the value of n k plus 1, then we get k plus 1 whole cube, which is equal to, again putting the value of n k plus 1 on the right hand side. Dear students, if we put the value of n k plus 1, then plus 1 will be 2. Then we get k plus 2 divided by 2, then whole square. So dear students, now this is the third step. Dear students, this is the third step, and now we are going to prove that this statement is true for, the given statement is true for n equals k plus 1. So let's take LHS. LHS is equal to 1q plus 2q plus 3q plus kq plus k plus 1 whole cube. So dear students, now we are going to prove that LHS is equal to RHS by using the first equation. So we know that 1q plus 2q plus dot dot plus kq, that means the sum of the terms to kth term is equal to k plus 1 by 2 whole square. So let's use the equation I, which is already true. k plus 1 by 2 whole square plus the last term k plus 1 cube as it is. So dear students, after simplification of this expression, we'll get exactly RHS equal to RHS. So let's take k plus 1 whole square common from both the terms. So dear students, if we take k plus 1 whole square and k plus 1 whole square common, then the remaining term will be k square. 2a square means 4 plus k plus 1. So dear students, now let's take the LCM. So if we take LCM 4, then we get k square plus 4 times k, 4k, 4 times 1 we get 4. So dear students, now let us do the simplification of this expression. K plus 1 whole square as it is, k square plus 4k plus 4. We can write this as k plus 2 whole square divided by 4. So dear students, now this expression we can write as k plus 1 k plus 1 times k plus 2 by 2 whole square, because a square is square, we can write whole square. So dear students, we have got exactly the value of RHS, k plus 1 k plus 2 by 2 whole square. That means the given statement is also true for n equals to k plus 1 when it is true for n equals to k. So dear students, now let us write down the conclusion. It shows that, let's write down the conclusion. It shows that pk plus 1. It shows that pk plus 1 is true. It shows that pk plus 1 is true when pk is true. Hence, by the principle of mathematical induction, so at last we have to write down the conclusion. Hence, by the principle of mathematical induction, Pn is true for all the natural numbers. Pn is true for, that means our given statement is true for all the natural numbers n belongs to En. So dear students, we have proved that the sum of the cubes of first n natural numbers is equal to n times n plus 1 divided by 2 whole square by using the principle of mathematical induction. So dear students, at first we have supposed the given statement as Pn, then we have shown that the given statement is true for n equals to 1. Then we have supposed that the given statement is true for n equals to k, and by assuming that the given statement is true for n equals to k, we have shown that the statement is true for n equals to k plus 1. And at last, according to the principle of mathematical induction, the given statement is true for all the natural numbers n belongs to n. So dear students, I hope that you have understood how to apply the principle of mathematical induction and prove the statement related to the natural numbers. Thank you. Thanks for watching this video. Next time we'll meet with a new content. Till then, bye. Have a nice day. Thank you.